In this video, I want to cover a technique that our book uses to solve equations by the method called variation of parameters. And I think it's good knowledge to know about Cramer's rule. So really in this video, I'm going to show you Cramer's rule. It may be a review for some of you. If you've had linear algebra, I'm sure you've seen it. You may have seen it in another algebra course. But anyway, it's a method of solving a system of equations by using determinants. So I'll explain all that if you're not familiar with that terminology. Cramer's rule is actually a theorem. And I'm going to show it to you in the smallest form, a system of two equations with two unknowns. a1x plus b1y equals c1, a2x plus b2y equals to c2. Where x and y are the variables, and the a's, b's, and c's are the coefficients in the problem. Alright, well, we can actually write down the answer for x and y. Now normally, we solve these equations by some kind of elimination or substitution technique. But I'll show you Cramer's rule. Like I said, we can solve the equation immediately. We can write x equals to the determinant of c1, c2, b1, b2 divided by the determinant a1, b1, a2, b2. And y, just to complete the thought, and then we'll talk about determinants, y is going to be the determinant a1, a2, c1, c2 divided by the determinant a1, a2, b1, b2. Well, there's a pattern to this, and notice the denominators. I'm setting up these coefficients. A1, B1, A2, B2 match these coefficients right here on the left side of the problem. And the right-hand denominator has the same determinant, same number really. Now the numerator is formed by replacing, for solving for x is the first column here. So if we replace this first column of coefficients with the right-hand side, C1, C2, and then I'll retain B1, B2, because we're not solving for y right here, then we get this determinant. Likewise, solving for y, I would replace the y column coefficients with the right hand side, C1, C2, and retain the other column, the x column. So that's the pattern there. And this can be, this works for larger systems, any size you want, as long as they're an equal number of equations, an equal number of variables involved. And but we're just going to stick with a 2x2 version here because of the size of the problems we're dealing with. Alright, now I'm going to erase this and just work a specific problem just to make sure this all clicks. Here's a small system of equations I made up. I'm going to solve 3x minus 4y equals to 5, 6x plus 7y equals to 8. And I'll solve it by Cramer's method. Now I can immediately tell that the answer we're going to get for this, if there's a fraction, the denominator fraction is probably going to be 45. Well, where does that come from? Well, when we look at the determinant of the left side, it is 3, negative 4, 6, and 7. The way you calculate a determinant, that's 2 by 2, is to multiply the forward diagonal, which is 21, and then subtract the product on the backward diagonal. So I'm subtracting negative 4 times 6. I'm subtracting negative 24. And that ends up being 45. So that's basically all there is to it for calculating a determinant that's 2 by 2. Now, you may have seen enough calculus to run into cross products and 3 by 3 determinants. Larger determinants are more complicated. So it gets more complicated. The larger the determinant, the method of calculation becomes worse. Okay, more complicated. But we're just sticking to the 2 by 2s because in the method of variation of parameters, that's the only size we deal with. Alright, so again, a determinant is calculated by multiplying down this diagonal, upper left, lower right, then subtracting the other product down this diagonal minus this product. Okay, well, let me write out the problem then with solving by Cramer's rule. X is going to be the top determinant. Because the x column, I replace these coefficients. I have 5, 8 with the right hand side. I'll keep the y coefficients, minus 4 and 7. And the denominator are the coefficients on the left side. 3, minus 4, 6, and 7. So let's go ahead and, well, let me write out y. Y would be, here we're going to keep the x coefficients, 3, 6, and replace the y coefficients with the right hand side, 5 and 8. And then divide by the coefficients on the left side, as before. So it's minus 3, oh, positive 3, sorry. Positive 3, negative 4, 6, and 7. Well, there it is. That's how you set it up. Now the top determinant is going to be 35, 5 times 7, 35, minus negative 32. And one more time, the bottom determinant is going to be 21 minus negative 24. And with this we get, these two negatives cancel, those two negatives cancel. So you get 67 over 45. Ooh, that's pretty ugly, isn't it? 67 45ths. Okay. And y would equal to 24 minus 30 divided by, and this is the same one, it's 45, as we've seen. So 24 minus 30 is negative 6 45ths. All right, so x would be 67 45ths, and y would be, and we could reduce that, divide by 3, get negative 2 15ths, minus 2 15ths. There we go. So that's the solution to that problem, and done by Cramer's rule. So from here, I'm going to derive the method of variation of parameters, and it looks pretty complicated, the derivation, but I think it's worthwhile to watch the proof. And now if you want the proof for Cramer's rule, you'll probably have to sit through a linear algebra course. But I am going to show you how the method of variation of parameters works, and then we'll work a problem or two.